Hope you enjoyed chapter 1. Our little fireside story chats here. I'm going to get into it today. Science of Human Behavior, B.F. Skinner. Chapter 2. Chapter 2, A Science of Behavior. The immediate tangible results of science make it easier to appraise than philosophy, poetry, art, or theology. As George Sarton has pointed out, science is unique in showing a cumulative progress. Newton explained his tremendous achievements by saying that he stood on the shoulders of giants. All scientists, whether giants or not, enable those who follow them to begin a little further along. This is not necessarily true elsewhere. Our contemporary writers, artists, and philosophers are not appreciably more effective than those of the golden age of Greece. Yet the average high school student understands much more of nature than the greatest of Greek scientists. A comparison of the effectiveness of Greek and modern science is scarcely worth making. It is clear, then, that science has something. It is a unique intellectual process which yields remarkable results. The danger, then, its astonishing accomplishments may conceal its true nature. This is especially important when we extend the methods of science to a new field. The basic characteristics of science are not restricted to any particular subject matter. When we study physics, chemistry, or biology, we study organized accumulations of information. These are not science itself, but the products of science. We may not be able to use much of this material when we enter new territory, nor should we allow ourselves to become enamored of instruments of research. We tend to think of the scientist in his observatory or laboratory with his telescopes, microscopes, and cyclotrons. Instruments give us a dramatic picture of science in action. But although science could not have gone very far without the devices which improve our contact with the surrounding world, and although any advanced science would be helpless without them, they are not science itself. We should not be disturbed if familiar instruments are lacking in a new field, nor is science to be identified with precise measurement or mathematical calculation. It is better to be exact than inexact, and much of modern science must be impossible without quantitative observations and without the mathematical tools needed to convert its reports into more general statements. But we may not measure or be mathematical without being scientific at all, just as we may be scientific in an elementary way without these aids. Some important characteristics of science. Science is, first of all, a set of attitudes. It is a disposition to deal with the facts rather than with what someone has said about them. Rejection of authority was the theme of the revival of learning when men dedicated themselves to the study of nature, not books. Science rejects even its own authorities when they interfere with the observation of nature. Science is a willingness to accept facts, even when they are opposed to wishes. Thoughtful men, perhaps always known that we are likely to see things as we want to see them, insisted of as they are. But thanks to Sigmund Freud, we are today much more likely aware of wishful thinking. The opposite of wishful thinking is intellectual honesty, an extremely important possession of the successful scientist. Scientists are by nature no more honest than other men, but as Bridgman has pointed out, the practice of science has put an exceptionally high premium on honesty. It is characteristic of science that any lack of honesty quickly brings disaster. Consider, for example, a scientist who conducts research to test a theory for which he is already well known. The result may confirm his theory, contradict it, or leave it in doubt. In spite of any inclination to the contrary, he must report a contradiction just as readily as confirmation. If he does not, someone else will, in a matter of weeks or months, or at most a few years, and this will be more damaging to his prestige than if he himself had reported it. Where right and wrong are not so easily or so quickly established, there is no similar pressure. In the long run, the issue is not so much one of personal prestige as of effective procedure. Scientists have simply found that being honest with oneself as much as with others is essential to progress. Experiments do not always come out as one expects, but the facts must stand and the expectations fall. The subject matter, not scientists, knows best. The same practical consequences have created the scientific atmosphere in which statements are constantly submitted to check, where nothing is put above precise description of the facts, and where facts are accepted no matter how distasteful the momentary consequences. Scientists have also discovered the value of remaining without an answer until a satisfactory one can be found. This is a difficult lesson. It takes considerable training to avoid premature conclusions, to refrain from making statements of insufficient evidence, and to avoid explanations or pure invention. Yet the history of science has demonstrated again and again the advantage of these practices. Science is, of course, more than a set of attitudes. It is a search for order, for uniformities, for lawful relations among the events in nature. It begins as we all begin, by observing single episodes, but it quickly passes on to the general rule, to scientific law. Something very much like the order expressed in a scientific law appears in our behavior at an early age. We learn the rough geometry of the space in which we move. We learn the laws of motion as we move about or push and pull objects or throw and catch them. If we could not find some uniformity in the world or conduct, we would remain haphazard and ineffective. Science sharpens the supplements this experience by demonstrating more and more relations among events and by demonstrating them more and more precisely. As Ernst Mach showed, in tracing the history of the science of mechanics, the earliest laws of science were probably the rules used by craftsmen and artisans in training apprentices. The rules saved time because the experienced craftsman could teach an apprentice a variety of details in a single formula. By learning a rule, the apprentice could deal with particular cases as they arose. In the later stage, science advances from the collection of rules or laws to larger systematic arrangements. Not only does it make statements about the world, it makes statements about statements. It sets up a model of its subject matter, which helps generate new rules very much as rules themselves generate new practices in dealing with single cases. A science may not reach this stage for some time. The scientific system, like the law, is designed to enable us to handle a subject matter more efficiently. What we call the scientific conception of a thing is not passive knowledge. Science is not concerned with contemplation. When we have discovered the laws which govern a part of the world about us, and when we have organized these laws into a system, we are then ready to deal effectively with that part of the world. By predicting the occurrence of an event, we are able to prepare for it. By arranging conditions in ways specified by the laws of a system, we not only predict, we control, we cause an event to occur, or assume certain characteristics. Behavior as a scientific subject matter. Behavior is not one of those subject matters which has become accessible only with the invention of an instrument such as the telescope or microscope. We all know thousands of facts about behavior. Actually, there is no subject matter with which we could be better acquainted, for we are always in the presence of at least one behaving organism. But this familiarity is something of a disadvantage, for it means that we have probably jumped to conclusions which will not be supported by the cautious methods of science. Even though we have observed behavior for many years, we are not necessarily able, without help, to express useful uniformities or lawful relations. We may show considerable skill in making plausible guesses about what our friends and acquaintances will do under various circumstances, or what we ourselves will do. We may make plausible generalizations about the conduct of people in general, but very few of these will survive careful analysis. A great deal of unlearning generally takes place in our early contact with the science of behavior. Behavior is a difficult subject matter, not because of its inaccessibility, but because it is extremely complex. Since its process, rather than a thing, it cannot easily be held still for observation. It is changing, fluid, and evanescent, and for this reason it makes great technical demands upon the ingenuity and energy of the scientist. But there is nothing essentially insoluble about the problems which arise from this fact. Several kinds of statements about behavior are commonly made. When we tell an anecdote or pass along a bit of gossip, we report a single event. What someone did upon such and such an occasion. She slammed the door and walked off without a word. Our report is a small bit of history. History itself is often nothing more than similar reporting on a broad scale. The biographer often confines himself to a series of episodes in the life of his subject. The case history, which occupies an important place in several fields of psychology, is a kind of biography, which is also concerned mainly with what a particular person did at particular times and places. When she was 11, Mary went to live with her maiden aunt in Winchester. Novels and short stories may be thought of as a veiled biography or history, since the ingredients of even a highly fanciful work of fiction are somehow or other taken from life. The narrative reporting of the behavior of people at particular times and places is also part of the sciences of archaeology, ethnology, sociology, and anthropology. These accounts have their uses. They broaden the experience of those who have not had first-hand access to similar data, but they are only the beginning of a science. No matter how accurate or quantitative it may be, the report of a single case is only a preliminary step. The next step is the discovery of some sort of uniformity. When we tell an anecdote to support an argument or report a case history to exemplify a principle, we imply a general rule, no matter how vaguely it may be expressed. The historian is seldom content with mere narration. He reports his facts to support a theory of cycles, trends, or patterns of history. In doing so, he passes from the single instance to the rule. When a biographer traces the influence of an early event upon a man's later life, he transcends simple reporting. He transcends simple reporting and asserts, no matter how hesitantly, that one thing has caused another. Fable and allegory are more than storytelling if they imply some kind of uniformity in human behavior, as they generally do. Our preference for consistency of character and our rejection of implausible coincidences in literature show that we expect lawfulness. The manners and customs of the sociologist and the anthropologist report the general behavior of groups of people. A vague sense of order emerges from any sustained observation of human behavior. Any plausible guess about what a friend will do or say in a given circumstance is a prediction based upon some such uniformity. If a reasonable order was not discovered, we could scarcely be effective in dealing with human affairs. The methods of science are designed to clarify these uniformities and make them explicit. The techniques of field study of the anthropologist and social psychologist, the procedures of the psychological clinic, and the controlled experimental methods of the laboratory are all directed towards this end, as are also the mathematical and logical tools of science. Many people interested in human behavior do not feel the need for the standards of proof characteristics of an exact science. The uniformities in behavior are obvious without them, and at the same time, they are reluctant to accept the conclusions toward with which such proof inescapably points if they do not sense the uniformity themselves. But these idiosyncrasies are a costly luxury. We need not defend the methods of science in their application to behavior. The experimental and mathematical techniques used in discovering and expressing uniformities are the common property of science in general. Almost every discipline has contributed to this pool of resources, and all disciplines borrow from it. The advantages are well established. Some objections to a science of behavior. The report of a single event raises no theoretical problems and comes into no conflict with philosophies of human behavior. The scientific laws or systems which express uniformities are likely to conflict with theory because they claim the same territory. When a science of behavior reaches the point of dealing with lawful relationships, it meets the resistance of those who give their allegiance to pre-scientific or extra-scientific conceptions. The resistance does not always take the form of an overt rejection of science. It may be transmuted into claims of limitations, often expressed in highly scientific terms. It has sometimes been pointed out, for example, that physical science has been unable to maintain its philosophy of determinism, particularly at the subatomic level. The principle of indeterminacy states that there are circumstances under which the physicist cannot put himself in possession of all relevant information. If he chooses to observe one event, he must relinquish the possibility of observing another. In our present state of knowledge, certain events, therefore, appear to be unpredictable. It does not follow that these events are free or capricious, since human behavior is enormously complex and the human organism is of limited dimensions. Many acts may involve processes to which the principle of indeterminacy applies. It does not follow that human behavior is free, but only that it may be beyond the range of a predictive or controlling science. Most students of behavior, however, would be willing to settle for the degree of prediction and control achieved by the physical sciences, in spite of this limitation. A final answer to the problem of lawfulness is to be sought not to the limits of any hypothetical mechanism within the organism, but in our ability to demonstrate lawfulness in the behavior of the organism as a whole. A similar objection has a logical flavor. It is contended that reason cannot comprehend itself, or, in somewhat more substantial terms, that the behavior required to understanding one's own behavior must be something beyond that behavior which is understood. It is true that knowledge is limited by the limitations of the knowing organism. The number of things in the world which might be known certainly exceeds the number of possible different states and all possible knowers. But the law and systems of science are designed to make a knowledge of particular events unimportant. It is by no means necessary that one man should understand all the facts in any given field, but only that he should understand all the kinds of facts. We have no reason to suppose that human intellect is incapable of formulating or comprehending the basic principles of human behavior, certainly not until we have a clear notion of what those principles may be. The assumption that behavior is a lawful scientific datum sometimes meets with another objection. Science is concerned with the general, but the behavior of the individual is necessarily unique. The case history has a richness and flavor which are in decided contrast with general principles. It is easy to convince oneself that there are two distinct worlds and that one is beyond the reach of science. This distinction is not peculiar to the study of human behavior. It can always be made in the early stages of any science when it is not clear what we may deduce from a general principle with respect to a particular case. What the science of physics has to say about the world is dull and colorless to the beginning student when compared with its daily experience, but he later discovers that it is actually a more incisive account of even the single instance. When we wish to deal effectively with the single instance, we turn to science for help. The argument will lose cogency as a science of behavior progresses and as the implications of its general laws become clear. A comparable argument against the possibility of a science of medicine has already lost its significance. In War and Peace, Tolstoy wrote of illness of a favorite character as follows. Doctors came to see Natasha, both separately and in consultation. They said a great deal in French, in German, and in Latin. They criticized one another and prescribed the most diverse remedies for all the diseases they were familiar with, but it never occurred to one of them to make the simple reflection that they could not understand the disease from which Natasha was suffering, as no single disease can be fully understood in a living person, for every living person has his individual peculiarities and has always his own peculiar, new, complex complaints unknown to medicine. Not a disease of the lungs, of the kidneys, of the skin, of the heart, and so on, as described in medical books, but is a disease that consists of one out of the innumerable combinations of ailments of those organs. Tolstoy was justified in calling every sickness a unique event. Every action of the individual is unique, as well as every event in physics and chemistry. But his objection to a science of medicine in terms of uniqueness was unwarranted. The argument was plausible enough at the time. No one could then contradict him by supplying the necessary general principles. But a great deal has happened in medical science since then. And today, few people would care to argue that a disease cannot be described in general terms, or that a single case cannot be discussed by referring to factors common to many cases. The intuitive wisdom of an old-style diagnostician has been largely replaced by the analytical procedures of the clinic, just as scientific analysis of behavior will eventually replace the personal interpretation of unique circumstances. A similar argument is leveled at the use of statistics in the science of behavior. A prediction of what the average individual will do is often of little or no value in dealing with a particular individual. The actuarial tables of life insurance companies are of no value to a physician in predicting the death or survival of particular events. This issue is still alive in the physical sciences, where it is associated with the concepts of causality and probability. It is seldom that the science of physics deals with the behavior of individual molecules, atoms, or subatomic particles. When it is occasionally called upon to do so, all the problems of a particular event arise. In general, science is helpful in dealing with the individual only insofar as its laws refer to individuals. A science of behavior which concerns only the behavior of groups is not likely to be of help in our understanding of a particular case. But a science may also deal with the behavior of the individual, and its success in doing so must be evaluated in terms of its achievements rather than any a priori contentions. The extraordinary complexity of behavior is sometimes held to be an added source of difficulty. Even though behavior may be lawful, it may be too complex to be dealt with in terms of law. Sir Oliver Lodge once asserted that though an astronomer can calculate the orbit of a planet or comet or even a meteor, although a physicist can deal with the structure of atoms and a chemist with their possible combinations, neither a biologist nor any scientific man can calculate the orbit of a common fly. This is a statement about the limitations of scientists or about their aspirations. not about the suitability of a subject matter. Even so, it is wrong. It may be said with some assurance that if no one has calculated the orbit of a fly, it is only because no one has been sufficiently interested in doing so. The tropistic movements of many insects are now fairly well understood, but the instrumentation needed to record the flight of a fly and to give the account of all the conditions affecting it would cost more than the importance of the subject justifies. There is therefore no reason to conclude that the author does, that an incalculable element of self-determination thus makes its appearance quite low down the animal scale. Self-determination does not follow from complexity. Difficulty in calculating the orbit of the fly does not prove capriciousness, though it may make it impossible to prove anything else. The problems imposed by the complexity of a subject matter must be dealt with as they arise. Apparently, hopeless cases often become manageable in time. It is only recently that any sort of lawful account of weather has been possible. We often succeed in reducing complexity to a reasonable degree by simplifying conditions in the laboratory. But where this is impossible, a statistical analysis may be used to achieve an inferior but in many ways acceptable prediction. Certainly no one can be prepared to say now what a science of behavior can or cannot accomplish eventually. Advanced estimates of the limits of science have generally proved inaccurate. The issue is, in the long run, pragmatic. We cannot tell until we have tried. Still another objection to the use of a scientific method in the study of human behavior is that behavior is an anomalous subject matter, because a prediction made about it may alter it. If we tell a friend that he is going to buy a particular kind of car, he may react to our prediction by buying a different kind. The same effect has been used to explain the failures of public opinion polls. In the presidential election of 1948, it was confidently predicted that a majority of the voters would vote for the candidate who, as it turned out, lost the election. It has been asserted that the electorate reacted to the prediction in a contrary way, and that the published prediction therefore had an effect upon the predicted event. But it is by no means necessary that a prediction of behavior be permitted to affect the behaving individual. There may have been practical reasons why the results of the poll in question could not be withheld until after the election, but this would not be the case in a purely scientific endeavor. There are other ways in which observer and observed interact. Study distorts the things studied. But there is no special problem here, peculiar to human behavior. It is now accepted as a general principle in scientific method that it is necessary to interfere in some degree with any phenomenon in the act of observing it. A scientist may have effect upon behavior in the act of observing or analyzing it, and he must certainly take this effect into account. But behavior may also be observed with a minimum of interaction between subject and scientist, and this is the case with which one naturally tries to begin. A final objection deals with the practical application of a scientific analysis. Even if we assume that behavior is lawful and that the methods of science will reveal the laws which govern it, we may be unable to make any technological use of these rules unless certain conditions can be taught under control in the laboratory. In the laboratory, many conditions are simplified and irrelevant conditions often eliminated. But of what value are laboratory studies if we must predict and control behavior where comparable simplification is impossible? It is true that we can gain control over behavior only insofar as we can control the factors responsible for it. What a scientific study does is to enable us to make optimal use of the control we possess. The laboratory simplification reveals the relevance of factors which we might otherwise overlook. We cannot avoid the problems raised by a science of behavior by simply denying that the necessary conditions can be controlled. In actual fact, there is a considerable degree of control over many relevant conditions. In penal institutions and military organizations, the control is extensive. We control the environment of the human organism in the nursery and in the institutions which care for those with whom the conditions of nursery remain necessary in later life. Fairly extensive control of conditions relevant to human behavior is maintained in industry in the form of wages and conditions of work, in schools in the form of grades and conditions of work, in commerce by anyone in possession of goods or money, by governmental agencies through the police and military, in the psychological clinic through the consent of the controllee, and so on. A degree of effective control, not so easily identified, rests in the hands of entertainers, writers, advertisers, and propagandists. These controls, which are often all too evident in their practical application, are more than sufficient to permit us to extend the results of a laboratory science to the interpretation of human behavior in daily affairs, for either theoretical or practical purposes. Since a science of behavior will continue to increase the effective use of this control, it is now more important than ever to understand the processes involved and to prepare ourselves for the problems which will certainly arise. Chapter 2 concluded. Man, well, whew. Tell you what, that one was a bruiser. That was a mouthful. There's a lot of reading on that one. Next one will be chapter 3, which we'll get to. I hope that you're finding value in this, and I hope, if anything, you're just having a laugh at how absurd that my setup is here. And you're just getting a little bit of a grin out of it. But yeah, in the words of Skinner, marvelous. See you next time.